So what I'm going to go over here is a quick proof of the Pythagorean theorem. And you notice I said a proof and not the proof, because there are actually quite a lot of very different proofs of this theorem. Obviously, there's the original going all the way back to the Pythagoreans, but quite a few people over the last several thousand years have given this some thought and come up with a variety of different approaches. The one we're talking about today, I think, is really kind of historically interesting. It shows that, these ideas can come out of nowhere, and a lot of people, not just mathematicians, can think about these things and come up with interesting ideas. This one was first kind of put forward in 1876 by the U.S. President James Garfield. All right, so here's what Garfield came up with. He said, look, I'm going to start with a right triangle, and I have the sides labeled A, B, and C, just like we usually do. I said, okay, now I'm going to make a copy of this triangle, and I'm going to kind of put it on here, stick it on the bottom, so that we get a straight base. You notice I've kept the side labels, right? It's the same. It's a copy, so the side lengths are the same, and it is also still a right triangle. All right, now let's fill this in. Right, I'm going to fill it in and create. Notice what I did here, right? I created a trapezoid. And you kind of have to turn it, right? If you rotate it 90 degrees, this side here is one of the bases. This is the other base, and this side here will be the height. And it's looking at it this way. The area of the trapezoid is 1/2 times the height, which is A plus B, times the sum of the bases. The first base is A, the second base is B. Now, if you use your FOIL method, it's going to be a little algebra mixed in here. If you use your FOIL method, multiply this out, this becomes 1/2 A squared plus 2AB plus B squared. Okay, that's one method. Right, that's one way we can get the area. Another way we could get the area is by looking at these three triangles, right? And there's three triangles in the picture. One way I could get the area, another way I can get the area is by adding the areas of these triangles together. Right, well, the area of this triangle is 1/2 AB. The area of this other triangle over here, this is also 1/2 AB. Okay, now I got to pause for just a second because I got to convince you of something. I got to convince you that that angle down there at the bottom, this one here, is a right angle. Okay, well, look. This angle here is the same as this one. And this angle here is the same as this one. So remember, the angles in a triangle, they add up to 180 degrees, right? So because this is a straight line here, right on the bottom, that AB, the base of the figure, this must be 90 degrees, right? It must be the same as this angle from the other two triangles. Okay, that means the area of this triangle is 1/2 C times C, which is 1/2 C squared. Okay, excellent. That makes the area of my overall trapezoid here 1/2 AB plus 1/2 C squared plus 1/2 AB, right? One of those 1/2 ABs came from here, the other one came from here. Right, now like I can simplify this a little bit, right? These two here, those are like terms. If I combine those together, this becomes 1/2 C squared plus AB. Okay, so these are two different expressions for one thing, for the area of this trapezoid. So since they both represent the same thing, they must be equal to each other. All right, so let's write that. 1/2 C squared plus AB equals 1/2 A squared plus 2AB plus b squared. Okay, now let's get rid of the fractions, right? Let's multiply both sides by 2. Okay, on the right-hand side, they just cancel. And all that's left is a squared plus 2ab plus b squared. And over here on the left side, I have to distribute, right? When I multiply 2 times 1/2 c squared, that's just c squared. When I multiply here, that's plus 2ab. Now, you see where we're going, right? I got one more step. Subtract 2ab from both sides. They cancel over here. All that's left on the left side is c squared. They cancel on the right. All that's left is a squared plus b squared. And there you go, right? There's our Pythagorean theorem, courtesy of U.S. President Garfield.